So,
Oh, you're kidding. Yeah, that's mowed down and moved, but what an experience
yeah.
that must have been.
Oh, it was amazing talking to Willie Mays and Bobby Bonds between innings. I mean, that was just an amazing way to grow up. So I've been a Giants fan ever since. So now that I
Hunter's
live in
Point.
Aurora, Colorado.
Yeah, you come back now and you will not recognize any of that area like most major city redevelopments.
Yeah, 'cause we lived in San Bruno, just south of the Bay, or of San Francisco. So it was a beautiful area.
Well, we'll get started in 2 or 3 minutes, get a few more people to load in here.
Hi guys.
Good morning.
Morning. Hey Ken.
How's it going?
Good, thank you.
So glad you're all able to make time for this and looking forward to it amidst the end of the year activities. And I'm sure you're like emptying out classrooms and drive-through graduations and all this other stuff going on.
Actually, I've got the opposite. I just started 3 classes last week.
Oh,
Goodness.
So summer session has started.
Wow.
Matter of fact, literally right after this class, I have half an hour before my office hours, and then I have classes until 10 o'clock tonight.
Oh my gosh. Okay, so is your office hour at 10 a.m. Pacific?
Yeah, office hours are 10 a.m. Pacific.
All right. Well, we'll aim for being done here at 9:30 Pacific. So halfway into lunch for the East Coasters.
Hello, Ken.
How are you doing?
I'm all right. A little behind, but doing okay. What
It's
about
no
you?
problem. I'm doing fine.
Wonderful. All right. Get myself set up here with a couple of computers. It'll be a minute.
Always helps, yeah, if you guys have an extra screen laying around, because we're going to be pushing things to the limit here.
So Ken, I had emailed you last week. I was having trouble on my Mac getting the MU editor to work, so I'm using the online Python instead.
Okay. Totally
What
fine.
What version of the Mac are you running?
The latest version, let me take
Catalina?
Yeah.
Yeah, there is some weirdness. I managed to get around it by directly launching the app and making sure I have permissions set to access any drive in the security panel. So if you actually go to the Mu editor in the applications folder,
Right.
do a control on that so that you can open up the contents.
Okay.
Then go to the actual application there. Let me bring it up too. So
Well, Robert, maybe we can do this at a later time so we don't interrupt what's going on
Yeah,
here.
no worries. At least you got the web version going, so.
Yeah, and it works. I had to change Macs,
Cool.
but that's another story.
Well, why don't we get started? It's 8:03, so we're already a couple minutes late. I want to welcome you all this morning to the Cyberbot Distance Learning Educator Workshop. You are now teacher 380 to 420 who have taken this class since early March. And usually we go out, do these in person, but we switched gears awfully fast. And we've had the tremendous support of the Cyber Innovation Center. In fact, introductions briefly. So I'm Ken Gracie. I've been with Parallax for over 25 years, and we make microcontrollers, educational tutorials, robotics. Many of you probably already know us. And I'm joined by several very helpful colleagues from the Cyber Innovation Center, nicecirc.org. Primarily, David Awalt is my co-host, flight commander. He's going to be managing Zoom and keeping this this airplane fly in the right direction, because it's near impossible to do all this stuff concurrently. And I also have Joe McAdam, who's going to help us with some technical issues when we get stuck, and Josh Coriel, who will do the same, and Claire Floyd, and they're all from NYSERC, who we'll introduce today and also on Wednesday. And then we have a lot of neat people hanging out here who I've known from different places and never met. For example, we welcome Katie from the Microbit Foundation. Hi, Katie. So she's here to build a robot. Today we're going to go about an hour and a half, and we'll try to end by 9:30 Pacific. If anybody wants to stay longer and really dive into some technical issues, we're going to do that. I can help you with that. The format of this is kind of open, but we have some specific objectives that I will tell you about. So about Parallax and NYSERC, who is our partner with this entire project. Parallax has been around since 1987, and we've made programming tools for microcontrollers since then.
This is Arduino, I don't know.
So David, you could mute them and then they could unmute themselves. And we have about a staff of 20, and NYSERC is our partner, as I mentioned. They've been in operation for actually about 10 years. I need to update this slide. They're funded by a grant through the Department of Homeland Security to create a cyber-ready education workforce. They have a whole bunch of curriculum for K-12 space, and we'll get a look at that too. We're an American company located near Sacramento, California. We do all of our manufacturing here. Now, you guys are from all over the place. Here's a map I made very quickly. So everywhere from here to there. And some up north that are probably cold and some that are very hot down south. I also asked you about your experience, and this is a brief summary of that. So you are mostly high school educators. We've got a few college and then some middle school, smaller amount of middle school. You have experience with a variety of hardware, ranging from sort of the STEM learning toys to engineering tools. And so a real span here, and that's what makes it a challenge for us to run these distance learning workshops, but we try to find a way to let those who need to run ahead really to do that, and then those who need help to get help right here. And then we also asked you just some general questions, and you're all excited about being here, and many of you interested in just making your coding classes, your computer science classes a lot more interesting by having physical hardware. And this will certainly do that for you. And several of you spoke of the cybersecurity connection. The microbit is really particularly useful for demonstrating some fundamentals because it has a built-in Bluetooth radio that is really easy to work with and super capable. For example, you may have seen all of those robots that were on my desk behind me. And those robots, just give you a look at them, can all be controlled concurrently from a keyboard. And I'm not talking about the ones up front, but those 12 robots in the back can be all driven openly from a keyboard, and we will show you how to do that on Friday. And you can add encryption and then security, and it makes a perfect demonstration platform. And by the way, we're 1 year into this Cyberbot effort. This started several years ago with NYSERC. They've been using our robots in their cyber literacy courses, and we decided we really needed one with Python and with more of a focus on cybersecurity. So we set out to make this 3 years ago, and for about a year, these have been becoming quite popular in class. Okay, how are we going to divide up these 3 days? So today, we'll introduce the Cyberbot, and I'm a real believer of learning by doing and discovering things as we go. So rather than front load this with how to use the editor or how the microbit works, we're going to use it and discover it. And we're going to do everything that way. And I think that's a good balance of satisfaction and learning at the same time. And you might want to use the same approach with your students. So we'll discover things and then trip on the way and then discuss them. So today we will connect up the microbit. We're going to write a few Python scripts. We'll introduce some of the educational resources, and then we're going to add a module to the microbit and calibrate 2 servos. So there are 3 big things really happening today: connecting the microbit to the editor, adding a code module to the microbit, and then centering, calibrating 2 servos. And I call attention to those because these are hurdles for getting started in some way. So I just want to bring them right forward and face them and get all the questions answered, because having put these in class for many years, we know exactly where people get stuck. Sometimes we design these things away from the system, but other times they're a very important part of engineering, so we leave them in. Wednesday, we'll look again at the educational resources, and we will really start driving our robots around. So we'll dive more into Python, and we'll use loops, functions, parameters, and then we're going to build a circuit together. So we'll throw in our first electronic circuit build, and it'll really be nice to do this as a group, because I think once we discuss the breadboard, the parts identification, and we've accomplished that, you can go on and build every circuit that we've got and code it. Friday, we will do Q&A, and we have a guest presenter doing the cybersecurity tutorials. That's Andy Lindsay, my colleague. And we'll talk about how to use this in class, and we're going to have an award ceremony. And for your goals, have a good time for now. I mean, enjoy this. Don't let it be intimidating. We all can do this. And just again, I want you to identify some of the gotchas on the way, and we want to go through those several times and become very familiar with them. So you'll also learn a little bit about how the Cyberbot interacts with the code module that's running in Python. And I also want you to get some experience. You're going to build a robot, get your questions answered, etc. We have some awards to give out this week. Everybody likes free stuff. And we've got a lot of wonderful accessories for the Cyberbot, and we'll send out 3 of them to our winners at the end of the week. We have 3 categories. The first one originated as soon as we all started working at home. Your coworker, which became your kids and pets and whatever. So give us your funniest coworker. The second one is your biggest fail. And then the third one is the biggest winner. So the biggest fail is just kind of a very obvious mistake that you made, oh duh kind of thing. And the biggest winner will be somebody between Wednesday and Thursday, or Wednesday and Friday, who really extends what they've learned by making a unique application. And I'll need all this material in, any of your submittals, video, pictures, whatever, by Thursday, not too late. So we could get these winners chosen. So here's one example. We saw a lot of snakes coming up for funniest coworkers. This teacher has 400 pets in his classroom, so he did not go home during the coronavirus shutdown because he has to go there and feed them all day, every day, and through summer. He has several of these ball python snakes, I think they're called. In terms of the biggest fail, it's really hard to catch them on camera sometimes, but this one we had to proclaim one of our teachers had the biggest fail because the microbit here was mounted upside down and on the wrong side of the board. And we were having trouble getting signals to the motors, so we could not center them. Nothing was working, so we said, give us a video of what you're doing. But you know, these things happen, and this is part of it is engineering. You go back and you realize the mistakes you made. You don't make them again. Sometimes it takes another set of eyes. So we're not making fun of anybody, but we want to see your trouble. This is a good example of a winner where somebody combined infrared object avoidance and whiskers. So the IR is working up to a foot or 2. So it's seeing the boxes. And then if it doesn't see something, there are some whiskers on the front of the robot that will bounce into it. For example, black baseboards might absorb infrared. Now for all of you, we want to hear from you as we go through this today. This is a meeting format. You can unmute your microphone, say whatever you want. We can share your video. So that feedback is important. Usually we do these classes in person and we can see what's going on. But as I mentioned, we're absolutely pushing the system here with Zoom by having 50 or 60 of you build and program microcontrollers over Zoom, asking you to set up side-by-side browser tabs, say one with Zoom and one with the Python editor. Who knows, you might even need to see a third tab if we're looking at something else, or be able to switch between. So we're asking a lot of you, but we found out it works and it's pretty effective. So I know you can do it. And I also, again, just want to remind you, unmute your microphone, jump in, and ask those questions as we go. So we're going to use a whole bunch of links today. Actually, mostly Wednesday and Friday, I would say. And I'm just going to paste this into the chat, this document, and you can go to this slide 17 if you want it. But these are what I consider the complete set of links for teaching a class using the Cyberbot. And the main one is really the parallax tutorials, which is the third item down. But the rest are really good supplemental material. And if you have some favorites, I want you to throw those in for us, or let me know and I'll add them here. And Katie from Microbit Foundation, I know you'll have some good ones to share with us on Wednesday, so we want to hear those too. This is one of my favorite books. This is the only other thing you really need to buy. It's a $10 book on Amazon, and it just really rounds out Python terminology and examples. And you can apply all of these to the Cyberbot. We have tutorials, but I found this book is just a great way to formalize some of the terms used and the interaction of libraries and doing everything from math to whatever. And before we get rolling, most importantly, all of you who are here today are running the class that your students will remember. Because all I remember from middle school, aside from being terrified by those dances we had to go to, was programming on a Timex Sinclair Z80. And it's, the chance to give students an opportunity to use their hands and be in charge of what they're doing that really makes them remember, retain, and learn. So that's what you're doing. Python's fun, and robots make it even more fun to learn. And I assure you that if you've ever wondered, you are definitely giving them interests, which generates careers later. And we want to know how it goes for you too. So why don't we just jump right in? Microbit. So this came out, I think 5 years ago. You can correct me, Katie, if you want. And it was produced by the BBC Foundation. They very successfully, in the 80s, put out computers in classrooms, the Acorn computer. And this time around, they decided, let's make something more innovative where every student can program on hardware. So they started out by putting several million of these in the hands of students. And you'll see it's very popular in elementary school, and middle school and high school, but especially at lower levels because it has a super make code block coding system, and you can easily control motors like these milk canisters, and use the LEDs and use the sensors on it quite easily. So you barely have to know how to read to do this. Make code is the location for all the block coding, and you cannot program the Cyberbot in that, but that's okay. So Python. For those of you who are new to Python, it's growing like crazy. It has the fastest rate of GitHub requests and commits right now, and is probably the third or fourth most popular language in the world. I like it because it looks like BASIC and I can read it and follow it. And it has a very a demanding way of forcing the correct syntax, which makes for good programming principles.
Ken, was that the title of the book you were talking about a second ago?
No, that book is Programming the BBC Microbit book, which if you look at my video right now, I have it in front of me. So it's on Amazon for 10 bucks. And links to these various articles are in the slideshow too, if you want to go back and check them out. So where did Python come from? Back in the early 90s, Guido van Rossum, who is was he Dutch or, yeah, a Dutch developer, went home for his Christmas break and developed this language, and became quite popular, especially for PC-based applications. And several years ago, 2 to 3 years ago, this gentleman out of Australia started a Kickstarter to make a condensed version of Python called MicroPython, which has everything a microcontroller needs. So if you program in Python on a computer, you know you can be very, very verbose, and it has lots of capabilities for databases and all kinds of stuff that you may not need on microcontrollers, because microcontrollers like to talk to I/O pins and other hardware, motors, sensors. So you need less of that stuff, and you need more commands for talking to hardware. So Damien here went out and reduced this down to a version which is still very complete. I've not found anything that's not there that I needed for robotics. And he called it MicroPython, and it's since been ported to several processors. So Adafruit has one. Here's the microbit. There's this ESP chip that's really good for Wi-Fi. Parallax, my company's actually putting it on our new processor. So very useful, and quite the impact he had. The microbit, what I really like about this is it's already loaded with a lot of stuff. And we have codes that I'll point you to for your homework after today that you can run. But just a super quick look at it, there's an LED display on it which can give you feedback. That's important in robotics because you want to know what your robot is doing or where the code is that it's running. So you can use that LED to show you which sensors are getting activated or what part of the program it's in. There are buttons on it. There is a Bluetooth radio, which is really nice to have in robotics. There's an accelerometer. So if your robot's driving and you don't want to use infrared or ultrasonic or whatever, there's actually a motion sensor that you can use to detect that you've run into a wall. There's a temperature sensor and a compass too. So yeah, the compass is great for robotics if you want to navigate a certain direction. And it comes in this little card format. You've all found that. For education, what I love about it is it runs on anything, and it does not require your IT department to install software. So you just have to be able to go to the Python editor online and you can get going. And having worked with a lot of embedded, if I use words, by the way, that you haven't heard, stop me, but embedded hardware, I call it, which is also called physical computing, microcontrollers. Having worked with a lot of these systems in 25 years, this is a real joy not to have to install software. It's just one big thing out of the way. So you could simply go to the browser here and start coding. In fact, you guys ready to plug in a microbit and just get this thing going? Use your, there's a little button you have on the bottom for, I think it's called reactions. Why don't you give me a thumbs up if we want to switch to some hardware programming now, and we'll make that breakthrough. You guys are looking for the button. All right, there we go. Okay. All right, so programming the microbit. Let's first get this connected and just look a little bit at the editor. And then we shall focus on adding a library. So first things first, grab your microbit and then connect it to your USB cable. And then connect that to your computer. And while you get things set up, I'm going to arrange my displays so they're side by side with the video camera and the Python editor. So David, I'll just reshare my screen here in a minute. Okay. All right, so now you should see my camera, my document camera, and then also my Python editor. So for you, what's helpful here is if you can put my Python editor, which would be my Zoom window, next to your Python editor, side-by-side windows. Y'all got that okay? Yeah? Yeah, I see some familiar faces to return for another round. Hi, Ashley. So we have some teachers that have come back to learn this over again, which is great. Okay, so once you've got this Python editor open, and it's python.microbit.org, /v/20 is a URL. And I'll just drop it in here. And if y'all are coming across other links, feel free to drop them into the chat. Okay, so the first thing I did is I used Control plus and minus on this window to resize it. So this is the plus version, and then here's the minus version. And as you go to minus, you'll see that the labels for the buttons on the top come back into view. So that's pretty important. So what I'm seeing here up top, I see the download, the connect button. We're going to talk about those two first. All right, so the connect button. There are two ways to get code into your microbit from this editor. There is kind of the clunkier way, which is creating a hex file, then dragging and dropping it onto a drive. And then there's directly flashing it. So I'll show you the clunky way first. When you opened up this tool, you have a program that was already here. So we'll just use this program and it will display a heart. So if I click on this download button, so now we're doing the clunky kind of verbose way.
Is it possible to ask a question?
Please.
Yeah, I think I'm lost from the get-go. The editor, does that come up from the microcontroller, or is it something we have to log on to?
So it's just to open it, this in your browser tab. So go to the chat.
Go to the chat.
Good morning, Ralph, by the way.
Oh, good morning, Ken. Yeah, I said hello earlier, yeah.
And then click on that link and you should open it up.
Oh, I'm working on another computer, so I tried this python.microbit.org, etc. And they gave me a whole litany of things I should select from.
Okay. I'm not sure what you saw, but we will probably just paste this link into a browser window and then a new tab, and you should be able to open it up. Let me know what you see there.
Microbit.
And we'll give that a second, and if not, we'll do a breakout room.
I'm sorry to slow this down.
That's totally okay. There are others that have the same question right now.
I know, that's that as a teacher as well. Okay, so I have your microbit.org, and we select, what do we select from here?
Okay, so you see the buttons, download and connect?
No, I see related links, robot projects, robot and robots.
Make sure you put in Python in front of microbit.org.
I have, oh, I think I've got something wrong here. All right, I'm really.
And so that link also, Ralph, is in the chat too.
Okay, so I'm sorry, I'm finally, I've arrived, and now you said what?
Okay, if you've arrived, then connect your microbit up.
Right.
Grab your USB cable, plug it in.
Right.
Okay, so now we'll go into the two methods of getting code into the microbit. All right, the first way we're going to do this is by making a hex file and then dragging it onto the microbit. So if you click on this download button, this will generate a hex file, and I'll explain later what the hex file is, and it will save it for you. If you're using Chrome, okay, it will save it in your downloads folder unless you have gone into your Chrome settings and told it to ask you where to store a file every time you download it. I'll show you how to do that. So when I clicked on download in my computer, it brought up a save as window asking me where I want to put it. So I'm going to put it on the desktop in my computer. So I'll save it there. So now there's a hex file on my desktop, and I want to put that on the microbit. So I'm going to drag it on there. So I'll open up a Explorer window and bring it into view here. Okay, and since I've plugged in the microbit, I should see it here on the left side. Here it is, microbit. It shows up as a hard drive. This is another innovative thing where no drivers were installed to make this appear. So I want to drag that hex file onto the microbit, and I put it on my desktop, and it is right here. It's called microbit program.hex. So I'll take that and I'll drag it onto the microbit. And once I've done that, it will run. So we'll download and run. So if you see now the microbit, it's saying, welcome hello world, I think, and then you'll see the heart. Okay, so that produced a file that the microbit can read, and then we dragged it on to the microbit, which ran it as soon as it was copied. So the other way to do this, which is the better way, and the way you'll use in class, and by the way, what I'm showing you now requires that you have updated your microbit firmware, all right? So a lot of things happening here, but provided you did update the microbit firmware like in the advanced email I sent you, this will now be possible. So now you can connect. So let's do this with the second button. Press connect, and then you will usually see a window come up and it says pair the device. And that's not pair as in Bluetooth, but that means attached to the device. So if you saw that window, and I'll see if I can get it to come up. I might have to unplug and then replug my microbit. Let me just see if that does it. So I go into connect. This is what you might see. And if you do, then you click on the device and you click connect. Okay, so now you can flash directly to the microbit. All right, so this will generate the hex code and then download it to the microbit from within this editor. So let's try it. Choose flash. All right, your program is in there. And just to see that it changed, I'll just put something else in there. I'll put Cyberbot on the text. Okay, so that's really hurdle 1 of 3 for today. And I'm curious, how are we doing out there?
So this is Charles, and I think in the future you might want to let us know that we need to install Chrome, because I have Safari and Firefox, but not Chrome on my machine. So I'm just having to download it now.
You got it. I'll do that. And I think this Python editor does work on other systems. Did you try it on Safari, by the way, and it didn't?
No, the editor's working with the normal download, but you cannot do connect and do the flash unless you have a Chrome browser.
With a Mac. Yeah.
Yeah.
Yeah, perfect. Yeah, the Mac is, so 80% of you are using Windows machines, but the Mac from a microcontroller programmer or developer perspective, from somebody who makes tools, is always the most challenging platform. So there are always, a little more limitations. You identified one. With Safari, you can't flash direct. You have to have Chrome. All right, so the other buttons here. Yep.
Can I ask another question?
You bet, Ralph.
A little behind here, but I had not updated my software, so I loaded the program you suggested, and I get a totally different pattern than the heart. I get an arrow and letter A, and so I'm wondering, can you show us the first version again? Which was that independent of the upgrade?
Sure. Yeah. So the first version is if you did not upgrade your microbit firmware, and it's just generating a hex file and then dragging it onto the microbit. So we'll do that again.
Please.
All right. So if you did not directly connect to it for flashing, you should see the left button called download. All right, so I will simply click on that, and it's going to generate a hex file and ask me where to save it. Now, I have configured Chrome to prompt me where to save files. If you haven't done this, then it will go to your downloads folder. The program that I'm saving is labeled here as microbit_program1 hex. I'm going to save it to my desktop. So I simply save it there. Okay, and then go into Explorer and drag it onto the microbit. So open up an Explorer window. And I want to be able to see the microbit on the left side. And I'd like to be able to see my program on the right side. So I just found it. Here it is. So I'll just drag that over to the microbit. And then it will copy it and run it.
And you had a download button on your screen. My button, I don't have a download button on my screen. ones, flash, disconnect, etc.
So your button says flash?
Yes.
Okay, then your firmware is updated and you don't need to do what I just demonstrated. So you could just flash your code. So go ahead and flash it and then you'll see the results. You should see for some text like hello world, and then you should see the heart.
Well, what do you know? Let's see.
Okay, success. And if not, we'll do a breakout room.
I don't want to hold this up any longer. I'm sorry.
Well, we got a place for you actually to get help because I have some super qualified people here. So
Yes.
Ralph, you still have trouble and we could do a breakout room.
Yeah, I think, well, I hate to miss what you're going through now.
No, don't worry. There's a video being recorded. I'm going to share it in an hour and a half.
All right. So okay, I guess,
Okay, so we'll move on. Do you need help?
Mr. Gracie,
Hi, Charles. Yeah.
quick question. Yeah, I did not receive a kit from your organization, but it doesn't matter. I have something is microbit based, and we have programmed it and taught in classes for other children in our summer camp before. So my question is, I'm not in sync with your program because I didn't get a hardware kit ready when you say plug it in and test it. So do I supposed to receive something from your organization?
Yes. So some teachers signed up for the Zoom side, but did not apply for the robot kit. So normally the way it works is you would apply for the robot kit, then we accept you, we verify you're a teacher, then we send you the robot, and then we send you a link for Zoom. So 3 or 4 of you signed up for Zoom, but did not sign up for the actual class, which initiates the robot. So provided you are, I could send you one. You're a teacher, right?
Yes.
Okay,
Yeah.
all you need to do, Charles, is send me an email. You have my email address, and I'll send you one out today.
I don't have your email address, but later maybe you can put
Okay,
in.
so I'll put it in chat for you right now.
Thank you. Thank you.
Sure.
Sorry, I slow everybody down.
Not at all, not at all. Okay, so before we proceed, does anybody want a breakout session?
Yeah, we're putting Ralph in a breakout room?
Yeah, Ralph,
no,
and then
wait. It came to life. I wasn't sure what I
Okay.
was looking for.
Anybody
It was a heart
else
and a message. Thank
need
you.
any help? Okay, yeah, so we have Michelangelo. So make a breakout, put Josh in there, Michelangelo, and whoever else wants to go and chat, and then they'll come back. All right. Thanks, everybody. Okay, moving on. Let's just look at one more thing here, and then we're going to jump right into adding a module to the microbit, okay? A code library. So the script name over here on the right side, I want to draw your attention to this. This is your default program name, and you can change it. So if I call it example program, and then I go and I want to save it, how would I do that? There's a load save button. So I'm going to click on load save, and this interface isn't traditional, what you're used to with file open and save. It's kind of a little bit unique, but once you learn to use it, it's fine. So you'll see 2 options with save here, Python script and download project hex. You always want to use download project hex, okay? So download the hex takes with it the code libraries that you've included. The script just saves a text file. So if I choose download Python script, I'm just going to get a text file of the code. But if I choose download project hex, that's the complete project that you can move between people and computers and others can run. So always use download project hex. So if I click on that, it asks me where I want to save it. Okay, and the name that it will use is the name I put under the script name. And you could use that load save button to open hex files as well. Questions on that? The serial button we're going to get to a little bit later. Okay, yeah, some big stuff if you've not used microcontrollers before, but if you have, you might be going, okay, yeah, this is easy, I understand this. So you got a yep.
Can I get a quick question? So when you save it through the Chrome web browser, it continually wants to drive it right to my downloads folder, and that's super annoying.
Yes.
How do I go in and change that?
Sure. I'll show you right now. So if you go to Chrome, the 3 buttons in the upper right, and then you click Settings, and then I think it is saved. Let's see here. Someone will find it before I do. Maybe it's under Advanced.
Advanced.
Yeah, and what is it called?
Downloads.
Downloads. Yeah, perfect. Someone's been here. Okay. So go to Advanced on the left side, Downloads, and then you'll see this slider, the second one, Ask where to save each file before downloading. Slide it to the right, and you'll be prompted each time.
Excellent, thanks.
Yeah, sure. It's totally helpful, and I can't live without it. Okay, so back into the editor, let's just make a change here, just so we know we can type code here. What I'm going to do is I'm just going to eliminate this first line, and I'm just going to make a flashing heart. This is kind of a hello world equivalent for microbit. And I will show this large heart, and then I'll show a small heart. And there's a whole list of predefined objects, images that you can write to the display, and you can scroll them, you can flash them, you can do whatever, one letter at a time, any way you want to do that. So there are commands for that, and I will take you there later and show you. So what I'd like to do is every quarter second, change it from a big heart to a small heart. And I'll reconfigure things here so it's side by side. And then I'll flash it. I'll leave my code up for a moment for you. Now you'll see the beating heart. And for those that don't want to miss a beat with typing in code, I'll also paste it into the chat for you. I'll give you a minute to try that
Excuse me,
out.
Ken.
Yeah.
But a question. So once you download a hex file, let's say you're doing the old-fashioned way where you have to download the file and then put it onto the microbit. You download the file on your local browser or on your local computer, and you want to make an edit on that file. So like you've got a program in there and you would like to edit it. How do you do that?
So you want to retrieve the program from the microbit, or do you want to? Okay, so once the program is on the microbit, you can't retrieve it and edit it and open it, but you can use load save to go back to your program, your original code. So you would go into load save and then click on browse for a file, this top box. And that will show you Python scripts and hex files.
Thank you.
Yeah, you're welcome.
So I understand I can't upload from the microbit and evaluate it, but the original default microbit game, can I download or upload that and hold that? Or is that available someplace else?
Yeah, so every time you open a copy of the Python editor, it will have that program as a default. So I'll do that right now.
No, I'm sorry. I may be being misunderstood. Built into the microbit, when you get it, is a program with an A and a B button and a whole bunch of LED displays. That default that is with the original unit, is there a way that we can grab that or reprogram that so that we can use that at a later time?
Yeah, I don't know. I'm sure that code is available on the microbit website. But Katie, if you know, put that in the chat.
Thank you.
Yeah, it looks like someone said, yeah, it's available. Good question. And so the question I answered, which I didn't understand, is you cannot retrieve, to my knowledge, the code from the microbit that you've already put on it, but you can open up and edit your original code. So if y'all had success with this, Yeah, okay. So the idea here was just to download, get a little bit familiar with the editor. You'll notice on top, from microbit import brings in the entire microbit code module. Okay, so this module has commands in it for display, for sound, for the radio, for anything you might do, random numbers, this kind of stuff. So we need to add a module for the Cyberbot. Okay, so that's where I'm going to take you now. And this series of steps is a little bit tricky, but once you've done it, it's really quite easy. So what I would suggest you do is just follow me first, and then you can do it on your own. Okay, and again, I'm showing you the gotchas. We're facing the hard stuff here head on. So we can get these hurdles out of the way, and we'll come right back to these issues on Wednesday and visit them again because they will not be clear to many of us, and that's okay. But these are the kinds of things that you have to know how to do well when working with students. All right, so our tutorials, which I've not mentioned yet, but they are here, and there are roughly 120, 130 pages of projects. It's pretty massive and it's growing. The one I'm going to take you to right now is adding modules to your microbit. So again, I suggest you just watch, and I'll do this kind of quickly, then we'll do it as a group. So I went to learn.parallax.com, I pasted that link into the chat, and I'm clicking on the add modules to your microbit. And once again, this will be recorded. I'll distribute the video, so if you don't catch all this, it's okay. And under this tutorial, there are instructions for how you add a module to your microbit. It's really nicely laid out for you, but let's just do it. You'll see the first thing is download the Cyberbot library archive file. Okay, so I'm going to click on that, and it's going to take us somewhere. It's taking us to the Parallax site. And with any microcontroller tool, you might be going to an Arduino library location, something for the Pi, it might be somewhere else, it might be in GitHub. All right, so this is just kind of basic computer usage, but it's tricky sometimes. So I'm going to walk you through it. And you'll see here we have 4 versions, and you always want the most recent one. The old ones are there for developers or for things we may encounter that we're totally unaware of until we encounter them. But I'm going to click on that, and it's a zip file. And I'm going to save it to my desktop. Now, in your case, unless you've configured Chrome to give you a save as location, it'll go to your downloads folder. So I'm going to put it on my desktop. And now I'm going to go to my desktop and unzip it. So here it is. And I'll do this inside of a browser window, so it's a little bit more, or a Windows Explorer window, so it's a little bit easier to see and follow. So I downloaded the Cyberbot MicroPython v080. Now I'm going to right click on it, and I'm going to choose Extract All. And I'll accept the default location, which is also on my desktop. Okay, now that is done. So I've extracted the entire contents of that zip. As I open this zip up, you will see here that there are example codes. These all go with the book. And there are circuits. This is kind of cool. These are all the pictures out of the book. I've not seen that until this moment. And then there are libraries, code modules that can be used with the Cyberbot. And the main one is cyberbot.py. That has all the basic bot functionality in it. You'll see there are many others too. They're for more advanced motors we might have, ultrasonic sensors, line follower, TV remote controls, or whatever. But the one we're going to add to the microbit is called cyberbot.py. So back into the microbit editor, Python editor, I want to add that module to my microbit. And here's how I do it. I click on Load Save, and then this top box, or browse for a file. I'm going to click on that link, and then I'm going to go to where I extracted the contents of that zip, which is the Cyberbot MicroPython v080 folder. I'm going to click inside of it, and I'm going to find cyberbot.py, and then choose OK. And it says the Cyberbot module's been added to the file system. Okay, so how do I know that? I'm not sure I trust that. Let's just go look. Click on Load Save, and you'll see now it says Show Files, and there are 2. So if I scroll down, there is my example program and the Cyberbot module. Okay, so now it's there. So now I could use that module. And what that means in my code is I could change this from microbit import star to from Cyberbot import star. Okay, and the Cyberbot module, by the way, includes everything in the microbit module as well as all the robot control stuff. Wednesday, I'll take you to the what's called the API, the programming interface for that module. But today the goal is just to get this servo centered. So let's,
Hey, Ken?
walk
Sorry.
you guys through this.
Ken?
Hi, Demetrius.
Hey, how are you? I got distracted. Take it away. Could I go to a breakout room?
Absolutely.
Sure.
Anyone else want to go? Just holler or put your name in chat. David will shuttle you over there.
Who was that?
I had a question.
Demetrius.
I had a question related. This is in the Chrome one. How do we do this in the Mu editor too?
Okay, so in the Mu editor, you have to put the cyberbot.py in the mu_code folder on your computer, and then you go to the Files button, and if you put the cyberbot.py in the mu code folder, then it will appear on the right side, then you drag it to the left.
Okay, so just each time that I want to do it, I just drag it, which will copy it directly to the microbit at the time that I flash it.
Yeah, let me know if you succeeded there, and if not, I can show you at the end.
No, I've done that before. I thought there was an easier way with.
Okay, yeah, I just got distracted. I can't get to download the software.
Okay, so the library. All right, want me to walk y'all through it again, and now you can actually follow me.
Okay.
Let's do that.
All right.
Hey, Ken, I have a question.
Yeah.
If we were to close the Python editor browser window, would we have to
Python library? So how do I get there?
upload again the Cyberbot module?
No. So once you put the module on the microbit, it will stay there. And you can use it. And you can verify that by coming back into the editor and clicking on Load Save. And you should see down under Project Files that you have 2 files once you've added it. You'll have your program that you wrote and then the Cyberbot module.
And if we were to reset the microbit, would we have to?
It'll stay there. Yeah, so it's non-volatile, which means the power cycling will not blast away the contents of it.
Okay.
Great question. So we'll walk through this again, and I will talk you through it, and then we can all do it in parallel. So yeah, this is what I meant when we're really pushing the use of distance learning. We're doing it right now, and this is great. If we can do this, there's an awful lot we could do with all the tools around us. So to start on this, I'm going to paste a link into the chat. And some of you may want to go on. You can do that if you want by looking at the slideshow, but anyone that does not have the module on, just follow along. Okay, so click on that link in the chat, and you're going to get a browser window that opens up. Give me a little visual feedback if it's going okay. Okay, so for Jackie, all right. All right, so you've opened up the page, and now you see what I'm looking at, which is a tutorial page. And the very first link on that page is the Cyberbot Library Archive. I want to click on that and download it. Oh, I'm sorry, when you click on it, it takes you to the location where the file zip is. So now you should see the page I'm looking at. Give me a thumbs up or something so I know you're all there. Okay, cool.
Can I ask that you just give us a second, or me a second, because I'm reading from one from the chat and putting it on here manually.
Sure.
just give us a second to finish. I can't think of how to do that quickly.
Yeah, and we're okay so far with time. You know, we're about where we should be. Within 10 minutes, we're going to move into the servo bit.
Add this module.
Okay, so once you've got this page, you'll download the Cyberbot MicroPython zip. And I'm getting the one on top. It's version 080.
Modules.
And again, in my case, I've asked Chrome to prompt me for where I want to save it to. And if you don't do this, it will be in your downloads directory. So I'm going to choose my desktop, where to put it. And then click Save. Okay, so now I've downloaded the zip. It's on my desktop. So what I'd like to do is go there and unzip it. So on my desktop now, I've found it. And I'm going to right-click it and extract all. And I'll just accept the default path. And it made another extraction of it for me. And now I can open it up and look at the contents, but we don't actually have to do that right now. We just wanted to download it and then unzip it. So now we want to switch back to the Python editor. Y'all with me?
No. What was it you downloaded? I'm sorry, I'm a little behind. What is
Okay.
it?
So you see this page I'm looking at, Ralph?
No, I see the page with all the squares with the things to select.
Okay, that would be this page, I presume, with the list of zip files.
Probably the page before that.
Okay.
I manually copied over the link, and it's a selection of squares here.
Let's try this. You can see the chat, right?
Yes.
I think
Okay.
he's on the list of tutorials page.
Oh, he is. Okay. All right. So yeah, I'll just scoot you forward a couple of page clicks here.
Yeah.
Click on the link I just pasted in chat, and then you will see a list of files that are on the Parallax site.
All right. I'm just doing this differently because I have two computers going, but it's all right. I'll figure it out later.
Oh, well, you need to figure out now. So let's do breakout room. So David, start a breakout room if you already have one. And let's put Ralph in there. And anyone else who wants to go there, we can put you there. But let me finish what I started first.
Please,
show you how to add it again. So I've downloaded, unzipped the file. So now I click on Load Save. All right. And you'll see in the top box, you can drag and drop a hex or pi file here to open it. So this is how you add a module to your microbit. So I click on or browse for a file, and then I'm going to navigate to the contents of that zip that I unzipped. And I'm looking for cyberbot.py. Once you found it, click on it and choose open, and the Python editor should give you a message. In my case, since I already have it, it's asking me if I want to replace it. I'll just say yes. Okay, so to verify that you've added it, click on Load Save, and then go down to Project Files and click on Show Files. And if you're looking at my screen now, you can see that it's there. So it's probably the biggest barrier to getting started here is this. Then the other one is probably just integrating robotics and code and problem solving in general, which is what the fun is really about. But this is one of those technical hurdles we all have to get over.
So Ken, this is Ben. I have two quick questions. One is, once you've done this on a project file, you can then share that with students. You don't have to have them walk through this, correct?
Yeah, you can do that. However, I would have them walk through this because it is a common skill for a microcontroller, physical computing of all kinds. But
Right.
yes, you can do what you described. Now you have a file, save it as a hex, you can share that hex.
And then the second question, once you've loaded this Cyberbot, I call it a library, but module, okay, I can do that. So does it not run the microbit library as well? Can you not have two libraries at the same time?
So in this case, if you opened up the cyberbot.py folder in a text editor, you'll see it actually includes the microbit one.
So why, when I changed it to Cyberbot, it wouldn't run the Beating Heart project?
Oh, it didn't?
No, it would when I just did microbit, but if I were running Cyberbot only, it wasn't doing it.
Oh, that's
that was true
interesting.
for me as well.
Okay, I'll have to look at that.
Happened for me as well. I just sent a message in the chat about it.
Okay, so when you went ahead and did this then from microbit import star, then it did work, of course, right?
No, it wouldn't do it when I had both for some reason either.
Yeah, it didn't do it when I had both either. It only worked if I had just microbit.
Okay. I'd have to look at that. Shouldn't be the case.
Okay, that's kind of what.
Yeah, that's a new experience for me. I've not seen that in the past, but I'll look at it after class today and find out, and then report back to you guys. So yeah, it should, Cyberbot import star should include all of those images, access to everything in the microbit import star. All right, so the reason we did this is because we need to be able to control our motors, and there is an important step in building the Cyberbot where you have to center these servos. Okay, so I'm going to show you how to do that now, and then you guys will actually do it. And this will take up the next half hour of our time. So what I'll do is configure my display to have a camera and code. Actually, we'll start just by having the whole thing be the camera. And I'm going to drag out some hardware, and then you'll actually drag out the same hardware.
I'm going to ask now for the.
It's a good time.
I fell a little behind, so I'd like to go to that breakout room.
Okay, David.
Ralph,
gotcha.
Ralph, you should have an invitation on your Zoom somewhere to join it.
All right, let me minimize this here, and I'll see.
Does anyone? Well, I've got all of y'all's undivided attention, as it should be. Does anyone else need to join a breakout room?
I don't have an invitation. I saw them previously, but don't have one now.
Okay.
Might be have to uninvite him and then re-invite him back.
I don't see an uninvite option here, but I'm just going to close all rooms and we'll start over. How about
Totally
that?
fine, yeah.
Josh,
So
get out of there.
if you're all looking at my camera image, in fact, maybe you could spotlight it now. David, if you could, spotlight my, I'll make sure it's shared so it's prominent to everybody.
Hey, Ken, just one quick question.
Sure.
Back on microbit, the Python, when you click on the load and save, so on that show files, what you see in there is what's on the microbit.
That's right, yeah. And so you'll see the program you wrote, which was downloaded to it, and then the library you added.
Okay, got it, thank you.
Okay, so what I'm going to do now, yeah?
When you, back to what he was asking about, I see my main, and then I see cyberbot.py.
Mm-hmm.
Do I have to change that so that it changes, like where it's microbit import, that library changes, or does it just stay with, like, does it know that it's there?
I'm not sure I totally understand the question. Ask it again. I'm going to open up the Python editor.
Okay, let me get back to the editor.
I think she's asking at the top, you changed from microbit import star to from Cyberbot import star.
I understand now. That's correct. Yeah, so I now have to name the correct library I want to use. So now I would replace that from microbit import star to from Cyberbot import star.
Okay, thank you.
Yeah, good question. And I should have addressed that. Okay, so I've added the module, and I'm going now to share with you the system I have on my desk, which is 2 motors and a microbit mounted on a Cyberbot board and a battery pack. And we're going to center the servos. So let's go back to the video display here. And these are the parts that hopefully you have handy. Yeah.
Should we be following along as you're connecting all of this stuff?
Yeah, so I'm going to have you connect these things up now, actually. So yeah, so get out your the parts that I referenced in the email earlier, like last week. So you should have the microbit already, the Cyberbot board, and then you'll have 2 flathead screws and 2 white washers. And I'll just take mine apart so we could do this together.
Yeah.
And I'll use the document cam to really zoom in.
On my kit, they were in a separate little plastic bag. People are going to be looking for them.
Yeah, thank you. If you have that bag handy and you want to show it up on the screen, that would be great. So I will take this apart and we will build this together and talk about how it goes together. Then we can use the new IPEVO document cam that I paid way too much for on Amazon because there's some virus thing going around and everybody was switching everything in their lives to Zoom. Sound familiar? Anybody else get gouged?
Oh, no.
A year ago, they're great.
Okay, that dog definitely, he experiences the pain. All right, so if you're looking here at the parts we're going to use, you see my document cam view now? See, I have 2 flathead screws. Pan head screw is round on top. A flathead one is flat and countersunk. There are 2 of those. And then there's 2 of these nylon lock nuts. So these are hex shaped. They're not round spacers. And then there's 2 of these acorn nuts, we call them. All right, so get those parts handy. I should be able to get a better focus than that. And let me know if you guys got the pieces. Give me a thumbs up. Okay, cool. All right, so I'm going to zoom out a tad now and let's look at the other parts that I have here. Okay, so I have here Cyberbot board. That's this. So get that out of the bag if you haven't done so already. And get your battery pack handy. Go ahead and plug in your batteries. And the first thing we're going to do is mount the microbit to the Cyberbot board. So I'll give you just a minute to get the parts together. And then I'll show you how to assemble the connection. So let me know if you guys are kind of at the same point I am. Maybe thumbs up if you're good. Okay. I see 1 or 2, maybe a little more response. Keep clicking that button. Okay, good. All right, yeah, and thanks for your
And the
patience.
reactions are not working.
Yeah, the reactions button on the bottom can get you a thumbs up or thumbs down. Okay, so how do we build this thing? This is documented in the tutorial, but we're going to do it here. And I just wanted you to have the experience of understanding this microbit can do a lot of things on its own before you put on the Cyberbot. And that's why we've not connected this system together yet. So I'm going to take the microbit, and from the bottom, okay, which is this side with all the silkscreen on it and everything, I'm going to put the screw through the 2 outer holes on it. And there's a little nylon lock nut. You'll put that over the screw and tighten it down. And that the shape of that flathead screw is going to self-align the contacts of the microbit to the little spring connectors that are on the bottom of the Cyberbot board, okay? So I've got one done. I'm just going to tighten it a little bit. You can do it by hand, but or if you have a small set of tools, you can use those. So putting the second one on the outside. This is kind of like painting with Bob, isn't it? Okay, so now I've got this assembly. Give you a closer look at it. Turn it over for you. So you see the screws are on the 2 outer holes. They go through. Yep.
What's the purpose of the Cyberbot board?
Oh, many. I think that'll be Wednesday's discussion. Yeah, when we really start using it, then we'll see what it's about. But in short, it provides all the electrical connections to the motors, and it has a microcontroller on it and circuitry on the bottom, which enables all the robotic projects we're doing. So the microbit on its own doesn't have the ability and the timing to do the many things we need in robotics. So we have a little processor on the board, which we manufacture to aid us in that regard. It's transparent to the programmer. So let's put this microbit on the Cyberbot board. So this is the way you do it. Turn it over. And once it's kind of there, you'll feel it's sort of springy. And we just want to tighten that down with the acorn nuts on top. And you could do this by hand. There is a funny little wrench in your kit, though. You could use a little black plastic laser cut wrench. Okay. So my microbit is now mounted on the Cyberbot board. Let me know if you all are there. Thumbs up if you are, thumbs down if you're struggling. We could do breakout rooms, okay. All right, good, yep, cool. Okay then, so let's go ahead and plug in the servos here. I'll show you how to do that by giving you a better zoom again. Try to get the lighting correct. Okay, so the mistakes that we will normally make on this step.
Oh.
Tell you what, I'm going to add a little more lighting here. Maybe this will help us. See if the focus can come into view. Okay, there's some terminology we're going to use, and it's going to be pins is one of the words. And you'll see these metal posts on the board. Okay, those, we call them I/O pins, and they are in sets of 3. And connected to them, they're labeled ground, GND, and then voltage, and then the top one is signal. And there's also B, R, and W. That means black, red, and white. So I'm going to plug in one motor to them. And by the way, these are on P18 and P19 on the top of the board. I should be able to get a much better view of that than I'm seeing right now. Let's just see. Okay, we'll try the manual focus for a moment.
And can you go back just so I make sure that I got mine on the right way? I dropped one of the things and I had to find it.
Sure.
Thank you.
Does this help you? Is that the picture you're looking for?
Yep.
Okay.
Okay.
That was enough for you? All right. Great. Okay, I'm just going to try to manually do the focus for a minute here. And the reason I'm taking my time on this is it's a sticking point for people.
Well, Ken does that. Everybody else good? Anybody need one-on-one?
I think I need a breakout room. I think I got something messed up.
I got you, Teresa. Here comes Joe.
Oh, you got Joe. You're in trouble.
Yeah.
Well, we'll roll with this, I guess, here. I'll mess around with this after today and try to get a better image quality for us on Wednesday. Okay, so anyway, there are three posts here, and they're labeled on top P18, P19. I want to plug the motor in. And the three connections on the motor must align with the three posts on the board, okay? Oh, that's the wrong way. Yes, white goes, of course, on top, like that.
You're plugging to P18?
Yeah, P18, and then you can plug the other one into P19 right next to it. There we go. How's that? That's kind of what we're looking for, right? There we go. Okay. So now you can see what I've got. So I've plugged the motors into P18, P19, and the white lead is closest to the silkscreen label that says P18 and P19. And the black one is closest to the breadboard, and of course the red one's in the middle. So if you just reverse things, your battery pack will get hot, but there will be no smoke being let out. Okay, y'all good with that? Okay, we're taking our time on this, and it's totally okay. All right, so next, I'm going to plug in my power supply, and then we're going to write some code, and we're going to center the servos. So I'll back out of this image a little bit so we could see everything I've got going on here. Okay, so I brought in a battery pack. I have fresh batteries in it. Remember, no junk box, junk drawer batteries, okay? I'm going to plug that into the jack. So now I have power on the board. In fact, when I put the switch on position 1 on the board, you'll see that this green LED lit up. Go ahead and do that. So your motors are plugged in. Hopefully your battery pack is plugged in. Now we need to plug in the USB cable. So go ahead and plug that in to the microbit. So zooming back on my whole system now. Okay. So I've got motors connected, I have power supply connected, and I have a USB cable. And I put the switch on position 1.
Okay, that was my question.
Yeah, and we'll put it on 2. So the difference between 1 and 2 is 1 powers everything but the motors. Sometimes with robotics, you want to test your sensors, but you don't want the robot rolling away, so use position 1. Position 2 will actually power the motors. But we first want to put some code into the microbit to center the motors. And the motors have on them a little potentiometer that we're going to turn very gently with our screwdriver to center them. And this is an important step. And in the tutorial, students overlook this and they just assemble the robot, but I'm not allowing you to do that. And they'll have a robot, no matter what signals they give to the motors, it doesn't do at all what they expect. That's because they didn't center their servos. But they come pretty darn close to center from the factory. So let's switch over to the editor now, and we're going to write some code to center the servos. Okay, so now that we've imported the Cyberbot library, we can use it. And
we're not seeing the code window yet.
Oh, great. Thanks for pointing that out. How's that?
That's better.
Okay, let me know if it's not big enough. I'll just actually zoom it in for you a tad for now, because I can do that. All right, so we brought in the Cyberbot library. Now we could use the bot command. So just follow along here and type this in with me. So I've said bot 18.servo_speed 0. And I'm just going to copy and paste that line and change the 18 on the second one to 19. Wednesday, when we get into Python more, I'll show you a few more tricks about using this editor. Like, for example, you can indent blocks of code like that using by highlighting them.
To write that, I'm sorry.
One more time, I was talking over you.
So mine is still the image heart where it looks like a beating heart. How do I get a new program?
Okay, so first you'll type it, then you'll download it. You'll flash it. So you haven't changed the program. That's why you see your original one still.
Okay.
Ken, could I go, since I went into that breakout room, I've got only 2 things left to connect. It's the 2 pieces that have the fans on the top.
Yeah, the motors. Mm-hmm.
Do they
That's
go
right.
in the far?
Yeah, they go into 18 and 19 on the Cyberbot board.
Okay, I got it.
Great.
While we're asking questions, whoops. Am I muted? Can I ask a question about?
Questions are welcome.
Ken?
Yep.
Yeah, I went into a breakout room as well and came back and saw this all assembled. I'm more familiar with the hardware than software. Can you tell me real quickly what was done here?
Sure. What was done here was the following. A series of things. So I'll just back up, show them quickly. Okay, so we mounted first thing we did is we mounted the microbit to the Cyberbot board, okay, using these 2 flathead screws and 2 spacers.
Okay.
And this is a tutorial that I'll direct you to afterwards and show you where it is, so I don't have to walk everyone through it again. And then I plugged in the motors to P18 and P19.
Right.
On that header. You're familiar with this from our other robots too.
Yes. Yes.
So that's done. Then I plugged in the power supply here.
Okay.
And then I plugged in the USB cable to the microbit. And then I verified that I have power by putting the switch on position 1, and I saw, whoops, I saw 1 green light come on.
Okay.
All right, so if I turn it off, that green light goes away. And by the way, you can download code with this board off. That will not be a problem. So back to the...
And you say there's a tutorial or there's a video of this?
Yeah, in fact, David, if you can just post that, I could take us there really quick. Yeah, let me come back to that, but it's under main lessons, and then it's actually part of this build your Cyberbot. Okay. But I'll bring you back there afterwards.
Real quick, Ken, we've had some people that their code says it's not running when they're flashing with the Cyberbot import, but the program is running with power on to the Cyberbot board.
And how do you know it's not running? So you mean, explain that again so I got it.
You can read it in the chat if you want to.
Okay.
It may be a little easier, but or one of y'all, Jackie, Keith, Susan, or Thomas,
Well,
feel free to hop in.
usually, if your code's, all right, there's usually something else going on here. So we got code, power supplies, connections. We got a lot of room for error. And I think it's likely just an error. Maybe the IO pin doesn't match the physical one you've connected, or the motors aren't turning because it's on position 0 or 1. It's something. There's always something. And it's a process of troubleshooting to figure that out. So I would need to see an example. So let's go ahead and flash this code that we've got, and then I'll talk you through this particular step. So I'm going to connect again because my connection got lost, and now I'm going to flash. Okay, and nothing happens. So here's a really good example. I downloaded the code, the motors aren't turning. So we need to power that side of the board. So if I put it on position 1, they still don't turn. If I put it on 2, my motors don't turn, probably because I've already centered them, but what will yours look like? Let me give you an example of what you might be seeing when you do this. And then we'll really talk about how to center these motors. Okay, so I'm going to copy my code into chat, and then I'm going to enlarge the camera so you can follow this. So there's the code in chat. You can copy that into the editor. Whoops, I only sent it to Jerry. For some reason, there we go. The Zoom chat leaves a lot to be desired, doesn't it? So you can copy the code out of the chat and into your editor if you'd like. And I have flashed the code, and this is the result. Okay. So if your motors are not turning, it's because you don't have your switch in position 2. Or if you see a message showing up on the microbit that says syntax error, it's because you did not add the Cyberbot library to the microbit. Okay, both of those are problems we can go through. So what are we doing now? Okay, this is about haptics. So we all got to think like surgeons for the moment, okay? We're all doctors. We have to be gentle. Although the parts are robust, we need to be gentle, and we have to actually use the tool carefully. And I've heard from many of you through the years that the student's first experience using a screwdriver was building a parallax robot. So I'm just going to assume that's the case. And when I do this, I want to show that I'm not holding the screwdriver this way, like I'm trying to turn a 440 screw into a metal threaded area. I really very gently want to handle it this way. And I need to be able to sense the feedback that I'm getting, because what we're turning here is a plastic potentiometer. Let's get a close look at it. And occasionally I will get motors back from teachers where students have really just unintentionally, really gronked things to pieces.
Let's see if I can try to reset.
And that's okay, I'll replace them. So you see that little yellow cross-shaped device?
Line 2.
That's a plastic potentiometer, okay?
What does it say? Line 2.
So I'm going to take my screwdriver and I'm going to put it in there very gently. I'm going to zoom out first.
Oh.
Because this is one of those things where you feel it as well as see the results. So put it in here. I'm going to hold the screwdriver in a way that I'm not applying much force. And I just want to feel that tip of it engage with the potentiometer. And I'm going to turn it, maybe like just a little bit, maybe like 1/8 of a turn, until that motor stops. If you turn it the wrong way, the motor will speed up. So as you notice, I turned it until that servo stopped moving. That servo is now centered. Let's look at our other one.
So that's the goal, Ken. They're slowly moving, and we want them to stop.
You want them to stop. Thank you.
Okay.
Yeah, so again, and I'm just going to gently turn that. Hardly any force being put on the screwdriver. Now, we don't need to really obsess over this motor not stopping. All right, if it vibrates a little bit or it still is moving, that's okay, because robots move. In general, we will not be working with stopped robots. So my motors are now centered. How about you guys?
So
Right.
if mine didn't turn, does that mean they're already centered?
If yours
Like I've got
didn't
green
turn,
lights on.
okay. If you didn't at least feel them move or something, you have 2 lights on, check that power supply, position 2.
Yep, I got
Okay.
position
And then
2. Yep.
let's make sure you're plugged in correctly. So I'll look at mine. I'm going to zoom in for you. And you'll see that
I do have a question about plugging in. Do they, because one side has a flat black side, and then the other side has I'll just make sure I know what I'm talking about. They've got the open side where there's got the
yeah, the female side is on the servo plug, and then they plug into the posts that are on the board.
And I find one of the easiest ways to tell is actually adjust the potentiometer, just turn it, and it should start to rotate, and then work it back to going 0 if it wasn't moving to begin with.
I didn't have them the right way. I've got movement.
Yeah, it's a great point you just made. And it is true. Some servos are really close to being centered and this doesn't matter. So if you've got movement, that's good. Then you could just, again, put that screwdriver in there very gently, adjust it until the motor stops turning. And you only have to do this once. Okay? Now, if we have trouble with this, we'll do breakout rooms. Let me tell you why we're doing this. I'm going to zoom out and pull a robot out to demonstrate. There are 2 ways you could build a robot, a parallax robot. I'm going to push that whole thing off to the side, bring in a robot, and put him upside down, or her. Okay. I like to assemble my robots this way so that the servo spline, it's called a spline where you attach the star-shaped thing, is closer towards the middle of the robot. Let me give you an example. And I know the NYSERC people are laughing at me because I obsess over this, and to them it's not important. Okay, so I put my screwdriver in alignment with the center of the wheels because you see the spline on the servo is not in the middle of the servo. So there are 2 ways you could put this robot together. You could put the motors in with the servo spline or the axle closer to the battery pack, which is what I've done, and that allows a tighter turn radius. Or you can flip these motors over, and then the spline will be here, and the wheels will move forward about 3/4 of an inch, and they will be more in this location. What that does is gives you a little bit of a more difficult turn because the weight on the back of the robot is higher when it's contacting the ground, and it may not turn as well on linoleum or really sticky surfaces. So I like to mount the motors with the wheels closer to the middle. It's just a matter of flipping the servos over. So our tutorials show you how to put the motors forward. And the reason we do that is because you can still access those potentiometers. So here, I can't really get to the potentiometer anymore the way I built this, which I think is the right way to build it. But if you follow our tutorials, the potentiometer will actually be here, and you can still adjust it after assembly, but you don't need to. So you wind up with a nicer looking robot this way, and one that turns better. Okay, so before we take questions, there are 3 big things you've accomplished here. You have added a code module to the microbit. You have centered servos. And what is the 3rd thing? Well, you've connected to the microbit. So 3 big things have been done. Those are all challenges when running a class. Okay, so from here, you are free to build the robot. I know you've all been waiting. I know Randy wanted to build it. Several others did. They refrained. It was a tough weekend, but good job. And having not built it now, you can build it a better way. So where are the...
I have a question. Sorry, so I've got everything set up, everything is put together. As soon as I go to 2, the little propellers on my motors slightly move, but then they don't really spin. And at no point when I turn using the screwdriver, do they actually move or spin. They just slightly turn and then they stop. Is that normal?
No. So they should turn consistently.
No, he's talking about when you first power on to the motor, there's always going to be a little bit of twitch on the servo. And yes, that is normal.
That is, yeah.
But then at no point am I actually getting it to spin.
Okay. So when you put the screwdriver against the potentiometer,
right,
and you turn the potentiometer a little bit, there is no spinning of the motor?
Correct. I'm slowly turning the potentiometer, and there seems to be absolutely no spinning.
Okay, so is your switch in position 2? Do you see 2 green LEDs like I'm looking at?
It is, yes.
Okay, and that's good. And did you download the code?
Mm-hmm.
Okay, and you didn't receive any errors when downloading the code.
Nope.
That means your okay. That means your Cyberbot module is on the microbit. So your connections for plugin down here. Let's get a close look at those on mine. Okay.
P7 or P18 and P19.
Yeah, you got that. And can you tell me if there's a little jumper installed next to the ports where you plugged it in? It should be right on this side. There's a jumper.
I don't know about a jumper, but there's a VIN and a 5V.
Yeah, it's good. Oh, do you see a little black plastic tab?
Mm-hmm.
Okay, good. So that connects the power, either VIN or 5 volts. So let's share your screen. Let's look at your code. That would be the next thing to do, just to verify. Go back through this one piece at a time.
And make sure the wire is white to the outside.
Thank you.
Yeah, the wire is white to the outside.
Yeah, white on the outside. So you download it, and nothing happens to the motors. They don't.
Correct.
Okay. What if you do this? If you put the screwdriver in, like mine are centered. I put the screwdriver in, I just barely move that pot, and they start to turn. Try that.
Okay. All right, I've had it as far as counterclockwise as I can go, and I'm going to turn it clockwise.
That might be the issue. So the potentiometer, the range of motion is probably 360 degrees. So somewhere in the middle is where you'll want to be.
Okay, even in the middle, still no go.
This servo doesn't move at all.
Correct.
If the batteries weren't fresh, would that affect it?
Yeah, that will.
Let me double check that.
So the motors will function, but the logic in the motors will not work if the battery voltage is below, say, 4 volts. This is often a problem. And then the other thing we would look for in your case is the attachment of the microbit to the Cyberbot board.
That's through the screws, right?
Yeah.
The only attach point. Okay, and it has to be as tight as possible, or?
Hand tight, yeah, pretty tight. It shouldn't be loose when you grab the back of it. You shouldn't feel any movement. So while he looks at that, I'm going to just take the others into the assembly tutorials for a moment, and then we'll deal with any kind of support help issues and make sure everyone's going. Okay, so if you go to learn.parallax.com, and I think I'm sharing the screen right now. Yeah, good. And then you click on Cyberbot, and you scroll down. I've jumped you through several pieces of this in different ways. You're on Build Your Cyberbot now under Main Lessons. And as you follow these tutorials, once you click on the tutorial, you'll see on the left side are like the pages of the tutorial. We'll call this the chapter. The chapter is Build Your Cyberbot, and then the pages are here on the left. So you've attached the Cyberbot board, and you can just go through these and assemble it. And as you click on one of them, like let's click on build the chassis, as you scroll down and go through these, you will see that the lower right side of the tutorial takes you to the next page. So here you would add the top side hardware and then just keep following the lower right onto the next page. And you'll take off that star-shaped plastic piece on the servos, and then you'll mount the servos. We have you lay out the parts. You'll see some animated GIFs to help you. And then here's the part I wanted to draw your attention to, which is I like to move that servo 180 degrees so that the wheel is here, back a little bit. I could annotate that. Let's see here somewhere. So my ideal situation is flipping that servo over so that your wheel is right there. Okay. And I don't know how to clear the annotation that I just did, so we'll leave it there. It's going to follow us for a minute. You'll install your battery pack and pay attention to all this. It's fun. Take your time. Look at this. This is important. We're using nylon screws here against the battery pack. You should have no choice but to use these since we use the other flatheads somewhere else. Attach your wheels and eventually mount the board on it. Okay, and I would like to impress upon you the importance of workmanship when doing this. So let's look at my video again. I'll send you links to this as well today, so if you're not getting it all, it's okay.
And Ken, under annotations, there's an erase.
Thanks. Ah, there it is. There's a whole bunch of cool stuff. And let's see here, clear. Good. Clear all drawings. Okay. So what would I like you to see about this particular robot? I think I'll use the annotation tool to demonstrate. First off, I've got the wires tidily arranged so that they are going in to the plugs and then under the robot chassis, so they're not in the way of the wheels and they're not in the way of any circuits we're going to put on the breadboard. Okay, so run them in a nice way, out of the way, and under the robot. So you'll see that they come out down here, and what you can do is pull them through and then take that slack and just kind of tuck it under the motors.
Hey, Ken, is there a right motor, left motor when we're plugging into the P19, P18?
Yeah, so 18 is your left and 19 is your right. And of course, you can always fix it in software, but you want to make sure you have 18 left so our tutorials run well on your robot.
Okay, great. Thank you.
Yeah, good question. So your homework will be building, yep.
Is that from looking at it from the front?
Yeah, another good question. So the front of the robot is here. And the reason for that is that the breadboard can be used this way to have sensors that interact with the environment. So for example, here's a light falling. Let's get something that's a little more visual. These are infrared emitters and receivers for wireless object detection. Sends out light and receives light. We put the sensors on the front of the robot, so as it goes forward, they're in a very useful place. And as another example, here's an ultrasonic sensor on a robot. That's the front. More questions like that? Okay.
Could you repeat which side is 18 the left and 19 is the right, or vice versa?
That's correct. 18 is left. Yeah, so in an hour and a half here, you just went through 3 or 4 hours of class if we were physically together. So pretty impressive. And you're all with me? Thumbs up if you are, if you're doing okay. All right, that's good. Okay, and it's okay if you're not, because we're going to help you out now as well, anyone that still has trouble.
So just to confirm, when you want the servos so that the potentiometer is facing the rear, not the front.
That's exactly correct. Yeah.
Okay.
Yeah, and we need to revise our instructions to reflect this. But the challenge in doing so is you have to assemble this circuit first. So it's a little bit of work, you know, to get it all right. To center the servos without putting them on the robot, you have to have this kind of setup. Or you can totally build the robot and center the servos while they're on the robot the other way. But we just have not revised our instructions yet. And there's no problem with following it as written. Yeah.
Can you explain why your preference is the wrong, I mean, the way that you do it instead of the nice arc way?
Mm-hmm. So my preference is based on this. The robot has a tighter turn radius. Let's say who has any Midwesterners out here have a 0 turn radius lawnmower? Well, if you do, you know that you can turn on a dime. Okay, by reversing the direction of the wheels. So in this example, I think you're looking at my video. This robot has a very tight turn radius. If I move those motors forward and they're here, the turn radius becomes wider. It's not, the back of the robot hangs out and it will catch on things. So if you're up against a chair or something, or in a corner and you turn, the back of the robot may get stuck. This is why a Roomba has motors in the middle, so it could turn very tightly.
And the only downside is it's harder to reach the potentiometers to center the motors later.
Yep, exactly.
Also, our way looks cooler.
This here we go.
And another thing is it depends on what you're gonna add on in the future. So it's a center of gravity issue.
100%. Yeah, you guys are teaching the class.
Yeah. If you push it out more, you're probably more stabilized. It all depends on your application.
Yeah, it's exactly it. So those are all robotic design issues. In this case, you got a gripper on here, and I'm picking up a piece of plastic. But as soon as I try to pick up what is something really heavy, you know, I need something heavy to demonstrate it. This Leatherman toolbox. See what happens to the robot. It starts to, well, that's not the best example, but yeah, it kind of leans forward there. Do you see that? Here's a better view of this same situation. See how the back of it stands up? So in this case, you know, with heavy objects in a gripper, it might be better to put the wheels the other way. But it depends on the project. You design the robot to fit the goal.
That's right. Perfect.
Yeah, excellent point.
And can you point to which wheel is supposed to be 18 and which wheel is supposed to be 19?
Sure. 18, 19.
Perfect. Thanks.
Yeah, and just to confuse a little bit, if you turn it over, now 18 is the right one, upside down. It's like flying an RC airplane. You know, when you're flying it towards you, their controls are reversed. Yeah, it ultimately, someone pointed out, it's a personal preference how you want to do this. So leave that up to you guys. I just got my favorite way and want y'all to think like me, I guess. So any other questions?
Well, yes. Can I ask a question?
Yeah.
So I wanted to know why when I look at my files that I loaded, the original one I loaded seems to have disappeared. I loaded before example and beating heart. They don't seem to be there yet. The new ones I've loaded, which were the servo program and the Cyberbot Python, are there. Are they in a different location?
It may have been, so in your editor, did you save the hex file at each step?
Yeah, I did download project hex, and originally I had both the first two examples in there. Then through that, with the help of Josh, I loaded the Cyberbot routine, and I loaded the servo program you just went through, and I don't see the other two. I'm wondering where they went
Are
to.
you renaming each one?
Yes, of course.
Yeah.
So you're allowed to store one main program on the microbit.
Right, but wouldn't on the editor itself, wouldn't they still be there?
Yeah, if you saved them, then you should be able to go and open them.
Okay, well.
And maybe that's what didn't happen.
What didn't happen?
Did you save them? So, like in my case here, I have this program. Let me make sure I've got screen sharing going.
Download.
Okay,
Yeah.
I'm sharing my screen.
Right.
And I would have to save it. So I'd click download project text. Okay, so while we go into the extended support, that's where we're going to go right now. Everybody can take off who doesn't want to stay. See you Wednesday, expect an email from me. For those who want to stay around for help, that's what we'll do now. So thank you. Okay,
And
so
if you're looking at the, oh, sorry. Go,
Bye,
please.
Ken. Thank you.
Just saying, if you're looking at the front of the robot, 18 is on the right.
If you're looking head on, so you're standing,
Head on.
it's coming towards you.
Yeah.
18 would be on the right.
Okay. Does that help you?
So Ralph, in
Charlie?
your case, so I have a program, I named it. I'm just going to call it Servo Center. And then I'm going to go save it. So to save it, I download it. Because right now it's in the browser. And then I'm going to save it to my desktop, Servo Center, here it is, save. And as I go look on show files, I see Servo Center and Cyberbot. Now I'm going to write a different program. I'll just change it and I'll make the speeds 100 and a minus 100. And I'm going to call it Servo Drive now. Okay, so saving it again with a new name is what I've done. So unless you did that, you would have your original program.
Now, here's where I went wrong, or I missed something. Download project hex, and then how'd you get to the Explorer then?
Oh yeah, okay. Are you using Chrome as your?
No, I'm not. I'm using Windows 10.
No, as your browser.
Oh, I'm sorry. I'm sorry. I thought you were asking me if I had a Chromebook. I beg your pardon.
That's
I'm
right.
using Chrome. Yes.
Okay, so in Chrome, you can go into the settings and prompt it to configure, to prompt it to ask you for a download location. So click on those three dots in the upper right.
Well, I went into settings.
Okay, good. And then go to advanced on the left side.
I'm sorry. Windows settings.
No, in Chrome.
Oh, I beg your pardon. Okay,
That's okay.
So I should be in Chrome. All right. So I'm in Chrome. Oh, the three dots. Yeah.
Three dots, and then advanced.
Three dots, new tab, blah, 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 blah. Oh, under downloads?
Downloads. And if you look at my screen too, I'm showing you where it is.
Let me go back here. Downloads. Downloads. Advanced.
Ryan, if you want to get started on your question, we could do that.
And where was your advanced? I'm sorry.
On the left side.
Yeah.
And then under it is downloads. And if you look at my screen, you should see this. Ask where to save each file before downloading. And you'll want to slide that to the right.
All right.
And Jameen, have you solved your issue?
He's in a breakout room right now.
Okay, cool. So you got that figured out, David, huh?
Yeah, Joe's back, so if anybody else needs to hop in a room.
David thinks he's the supreme leader at Zoom, and he's far from that.
I am the supreme leader. I have ultimate control.
You guys have been very helpful behind the scenes.
How do I get to another room? Mine's not even working.
Ryan, maybe we could just do it right here, unless others have kind of general questions as well. They might learn from what your issue is.
So
I'm wondering, go ahead. Sorry.
Yeah, let's take Ryan's question. And Ralph, maybe breakout room with yours.
Yeah, let me do that because I'd like to assemble the servos as well, which
Okay. So David, take Ralph to breakout room with Joe. Ryan, let's take your question.
So back to the question I asked a long time ago. Right now, it's not even downloading, so I can't get anything in there. It's only shown the original two.
Okay, let's do this. I'm going to give you co-host ability. Or David, can you give Ryan co-host and we could have him share his screen?
I just have laptops, so I have one computer on Zoom and the other with the...
That's okay. Oh, I see. So you can't show us the screen you're using for editing. Okay.
And
all right.
Only 18, when I put it on 2, will move the servo at all. The other will not move no matter what. I mean it.
Okay, is it plugged into 19?
18 and 19 are plugged in, yes.
Okay, so the other one moves, one doesn't, and your code speaks to both servos, right?
Well, I can't even run my code.
Okay, that would be one problem. So let's go back to that. Do you have the Cyberbot module on your microbit?
Yes.
Okay, let's verify it.
So under project files, show files, cyberbot.py.
Okay, so you see that. That's good. That's the first thing to look for. And then the second thing would be your code that you've downloaded.
Okay, I named it like you just did, servo center. That's not on the loader save. How would I get that on there? It only shows 2 files. It doesn't show that one.
Okay, so it will show up on the microbit when you flash it. So it won't be there right now. Well, actually, it might be shown, but it's not running on the microbit. So your code looks like mine on my screen right now, you could see.
The only difference is bot 18 is on line 3, but everything else is identical.
Okay, yep, sounds good. And then you have the flash button, so go ahead and flash.
I don't have a flash button.
Okay, do you have, does it say download?
Yes.
Let's try first the second button to the right where it says connect.
Okay.
Click that, and did it connect?
And it says no compatible devices found.
Oh, is your microbit plugged in?
Yes. It used to have, like, I'm on a Mac. I don't know if that's...
Okay. Yeah, let's do the drag and drop with the hex file in your case then. So it might be, are you in Safari?
No, Chrome.
Oh. Okay, did you update your microbit firmware?
Yes.
That shouldn't be a problem then. Yeah, so if your microbit is plugged in, then you should be able to click that connect button, and then a prompt will come up to connect it.
It says, please reconnect your microbit and try again. So I unplug it and plug it back in, and then the same thing.
All right, well, let's try this then. Let's just generate the hex code and then drag it on to the microbit. So click on flash.
I still don't have a flash button.
Look in my microbit editor for a moment.
Uh-huh.
A far left button should say flash.
And mine says download.
Oh, if it says download, then you are connected. So click on it.
Okay.
All right. And
there is no application set to the document servo center .1 hex.
That's the message you get?
Mm-hmm.
All right, I'm not sure what that means, but let's back up and try the other method then of just making a hex file. So on the button that says disconnect, press it.
Disconnect?
Yeah. Second button from the right, from the left.
Okay.
And then your far left button should now turn into download. Did that happen?
So it never says disconnect, it just says connect. I click it and it says no compatible devices found. It used to have a little drive, like I was trying to say before, on my desktop that said microbit, and now it doesn't have the microbit drive. So like I'm missing the driver.
Oh, so there's no driver. It shows up as a hard drive.
Yeah, exactly.
Okay,
That's what
so
I'm trying to say.
yeah, if it's not showing up, then unplug it and plug it in again.
Yeah, and I've done that like 10 times.
And it does not appear in your Finder.
At first it did.
Huh.
At first it really did.
I'm having the same issue as him. Once after I connected it to the Cyberbot board, I haven't been able to flash it. I haven't been able to connect it.
So Carl, you're also on a Mac or Windows machine?
I'm on a PC, and I use this. I used the microbit a ton over the past week with the new editor, and I was able to flash it. But ever since I've connected it through to the Cyberbot board, I haven't been able to flash it.
Why don't you disconnect it?
Yeah, and I've tried that.
Okay.
I've tried using a different USB cable.
So now it just doesn't appear again.
Yeah, it's weird. I don't know.
If you so that we could rule out the Cyberbot board as being the problem, if you take those Acorn nets off, let's see how it performs without the Cyberbot board, and then maybe it was an assembly issue or a power issue. So we'll back you up.
You want me to do the same?
Well, yeah, Ryan, maybe so. Yeah. I usually go backwards and try to isolate the problem out by going to where things did work and then go forward again. So while these guys, Ryan and Carl, take their microbits off, what other questions do we have?
Now it's working, Ken. Well, it's letting me flash now. The flash button's there.
Okay, so now you're disconnected from the Cyberbot board, right?
Right.
Okay, let's go ahead and reconnect it then. And so when you do this, Carl, let me ask you some questions. You probably already got it right, but I just want to be sure. I'm going to share my camera view again. Okay, so the bottom of your board will look like this. So the microbit will be basically upside down.
Right. Mm-hmm.
All right, and then you have the two screws, the flathead screws.
Yeah.
And then in between the Cyberbot board and the microbit is a little white hex.
Yeah.
Okay. Hex nut, you have that on, and then you have the caps, Acorn cap screws on the top.
On the top.
Okay, cool. So go ahead and put it back together. And maybe a little beyond hand tightening here would be good.
Okay.
Give it a little bit of your